Hello friends, today I am starting my new channel. I welcome all of you in my new channel. This channel I am starting for the purpose of developing confidence in myself. Since I have tried to start something new, that is I am researching for many days on that topic. That was the topic today I am introduced to all of you. I am introducing today is a story in the form of storytelling, a scientific theory. I try to uh, I try to give you a scientific, authentic scientific theory in the form of a story. I am researching on that for many days. I I see many books, I read many books, and I go on many websites and research about that so much. Now I am come in front of you to taking this video. Since if there is any issue, any if you think that there is any problem in my concept or any mistake in my video, then you can comment and say me what I do wrong. And if my English was not so good, then you can also comment that it's not good. You have to develop it, or you can give me your advice. I am thankful for it. And today I'm starting a story, a scientific story in the form of a story. Are you ready for that? Let's start this. This is the story of the universe that gave birth to us all. The entirety of boundless space and time, including all form of matter, energy, and celestial body, such as galaxies, stars, planets, satellites, etc., are all collectively termed as the universe. Now, we know the definition of universe. What is? Let's we see what's cosmology. What is cosmology? The study of the universe is known as cosmology. Cosmology is a field dedicated to understanding the origin, evolution, structure, and ultimate fate of the universe. Other hand, astronomy focuses on the objects within the universe. Some people confuse in them. I will clear that what's cosmology and what's astronomy. It's very easy. Astronomy is the study of objects within the universe, where cosmology is study of universe itself. That is a key thing. Very clear difference. Now come at the series scale of universe. The series scale of universe is mind-boggling. Its dimension can't be imagined. It is difficult to estimate its immense size, the countless stars, and its total mass. But attempts are made to estimate this using very large number of data. Contents of hundreds of billions of galaxies and hundreds of billions of stars in each galaxy. This puts the total number of stars in the observable universe in the astonishing range of 10 to the power 22 to 10 to the power 24. You can imagine 10 to the power 22 and 10 to the power 24. Many theories have been proposed regarding the universe, but the most accepted scientific theory for the universe origin is the Big Bang model. It posits that about 13.8 billion years ago, the universe began from a singularity, a state when there was only a hot and infinitely dense point. From that hot and infinitely dense point, the universe began to expanding and cooling. To put it simply, we trace the expansion of the universe backward in time. Then, according to Einstein's theory of general relativity, we arrive at a point of infinite density and temperature, where all the matter and energy of the universe are concentrated in a region of zero volume. You can imagine. This is the classical definition of the Big Bang singularity. What's similarity? It's clear. A similarity is a point where the known laws of physics, including general relativity, break down. Because the equations produces infinites for density and curvature, which signals that theory is no longer applicable in that extreme environment. However, it's also important to note that modern physics, particularly the quest for a theory of quantum gravity, suggests that this picture may be incomplete and that the universe may not have started from a literal point of zero volume. You can from this single point, the universe began. You can imagine that a single point from where the universe began, that is infinitely dense point and very hot, very having very high temperature. You can imagine that point. Think about that. From there, our universe comes. We can start to expand. Okay, as the universe expands, elementary particles form, which eventually come together, forming the first star and galaxies. From this, we conclude that the Big Bang described the rapid expansion of space itself from an extremely hot and dense state known as the singularity. This similarity is also you can see in black holes, but you can see this similarity on black hole also. But we are not describing black holes. It's another topic and it's a huge topic. Since I'm not going on that. We are on Big Bang since we talked about that. Sometimes sometimes always, maximum times, scientists and teachers use help of black hole singularity to explain the singularity of Big Bang. But I am not doing that. So if you have any problem, you can say me on comment section. Let's discuss some misleading concept about this topic. Many think the singularity was a teeny ball of matter in a pre-existing body. I am saying no. This wasn't a teeny ball of matter in empty space. It was everything. It was everything. It containing all of the universe, space, time, and matter and energy. Can you imagine that? The real meaning of Big Bang was it is an explosion or an expansion. This questions arises. A questions arises. The first confusions people have, I am explained to you that the singularity is a pre-existing one. No, I am told you that not. And second questions arises that what are the real meaning of Big Bang? It is an explosion or expansion. Was it an explosion or expansion? What is it? Now I give the answer of that. The Big Bang is not an explosion into space. It's the rapid expansion of space itself. It is the beginning of the universe. Rapid expansion from an extremely hot dense state, not an explosion in the traditional sense. The Big Bang is the entire process of the universe beginning and its ongoing expansion. Another question arises why it was not an explosion. Why Big Bang was not an explosion? The answer is conventional explosion like a firecracker happens within a pre-existing space. The force of explosion pushes matter outwards into the space. The Big Bang wasn't fundamentally different because it was the expansion of space itself. This theory was not a guess. This was proposed on many data, based on many data. This theory was proposed when astronomers using advanced telescopes and other scientific instruments observed that our universe is continuously expanding. The Big Bang Theory is not just a guess. It's supported by several key pieces of observational evidence, including expanding universe, CMB radiation, and abundance of light. Let me talk on the first topic of the evidence expanding universe. What is that and how our universe is expanding? Astronomer Edwin Hubble observed that other galaxies are moving away from us. Other galaxies are moving from us, and the farther away they are, the faster they are receding. This observation, known as Hubble laws, indicate that the universe is expanding. Let we see the second evidence of Big Bang Theory, cosmic microwave background CMB radiation. This is the afterglow of Big Bang. CMB is the afterglow of Big Bang. It is a faint radiation. It is a faint thermal radiation that fills the entire universe. It is the oldest light we can observe in the universe. The two American physicists, Bob Tyke and Jean Peebles, working on a suggestion made by George Gamow, the early universe should have been very hot and dense, glowing white hot. That was the white hot. They argued that we should still be able to see this glowing because light from very distant part of the early universe would just be reaching us now and appear to us now as microwave radiation due to the expansion of the universe. At roughly the same time, it was accidentally discovered in 1965 by Arno Penzias and Robert Wilson, providing a powerful snapshot of the early universe. The CMB is also the first light that could freely travel through the universe, as before that time the universe was an opaque plasma. Abundance of light elements, the third evidence. The Big Bang model accurately predicts the observed ratio of cosmic abundance of light elements like hydrogen and helium. Now, this will not stop here. We will begin to see the development of cosmic model in different regions of the world and how they all have important contribution in the fields of science and cosmology. In our next video, we will soon come soon. Wait for us. Thank you. If you like this video, uh, please subscribe and share. Thank you.